Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This will be another final exam simulation where basically what we will be doing is the same as the previous video. I will be doing a simulation of answering this exam question, the final exam question, and we will try to do within the allocated time. So as usual, let's take a look at the cover page. So this end of semester examination, we have 3 hours of time, and then in this case we have 4 questions in 8 printed pages. You can try side by side and we'll solve this together. Of course, I will be discussing some of the strategies, some of the things to take note of, etc. As we go on together. Of course, if you have attempted this paper and you just want to see the final answer, whether it match or not, you can straight away go to when for each question we have reached the answer. Right, feel free, whichever way this video can be of help, please utilize the video. So without further ado, let's go towards this paper. So right now, the time is 9:57 p.m. almost 10 p.m. 3 minutes before 10 p.m. So meaning that for 3 hours paper, it will be until 10, 11, 12, 1. 11, 12, 1. So meaning before 3 minutes before 1 a.m. I should finish this paper, right? Because if you take that block of 3 hours. Alright. So let's take a look. We have 4 questions. So basically the question is, as you can see here, question 1, 25 marks. It has part A and part B. Question 2, 25 marks. It has part A and part B as well. Question 3, also 25 marks. It has part A and part B. And question 4, 25 marks as well. It has part A, B, and C. And then we have the appendix of this table. So meaning what? We have 4 questions which have, of course, under each question it has multiple parts, but each block of the question is it is allocated 25 marks, meaning that each question carry a quarter of the full marks for the final exam. So in terms of our time allocation, we can divide the 3 hours into 4 equal time portion, meaning 45 minutes, 45 minutes, 45 minutes, and 45 minutes. Right. So without further ado, we'll go straight to question number 1, and we'll allocate 45 minutes for that at most. So it should be before 3 minutes before 10:45, right? So let me note down here. So from 10 to 10:45. I'll take note of the time as such, even though of course we know that we have begin 3 minutes before 10, so we'll just minus 3 minutes. So but it's easier for me to think of 10 to 10:45. Alright, so without further ado, let's go and answer the first question. Okay, so this is the first question, question 1A. So we have the figure here. Figure 1A shows a structure consisting of 2 members, A, B, C, and CD. So we have A, B, C over here and CD over here. Determine the support reaction pin at A, rocker B, and SMOS peg C, and pin D. So let me use this one just to illustrate what we have to find out. Because first, always the first step of answering is to really understand the question. Right. So we have 2 members. So member this one and this member, and then we need to find support reaction at A. So here, so obviously this is pin. You have AX and AY, and at rocker B. So this is a rocker. So obviously it will have a normal reaction upwards. So we have to find that one. Smooth peg C. So we have to find what is the support reaction here. This is a smooth peg where it is free to move along this axis. So we'll have, but it is restricted movement in this axis. So you have a support reaction or normal reaction there, and then at pin D. So we'll have this is pin, so we have X and Y component, right? So that is what we need to find. So let's proceed to answer this one. So let's put this as alright, so we'll put it there. We'll first take note of what is the important information, and then we can answer. Alright, so this is Bismillah. This is question 1A. Right, so we have to find basically AX is what, AY is what, and then NB is what, and then NC is what, and DX is what, as well as dy is what. So those are the unknowns that we have to find, right, at A, B, C, and D, right? So let's first draw the free body diagram. So we have two members there, so free body diagram. So on the left we have this member basically, so this member here, where we'll have AX and AY, and then we have a moment there, and we have a normal reaction at B, and we have support reaction at point C here. That one will correspond to that member there. Okay, let me okay, something like this. So this correspond here, and then we have force like this, and then we have dx dy. Let's assume this direction. Alright, so here it is 800 Newton. So this is a normal reaction, so we have normal C, so corresponding to it we'll have something like this, normal C, right? And then here we have NB, so we have here AX, AY, and the value is it given 600 Newton meter. 600 Newton meter. And in terms of the distance, so we have 2 meter. This distance is 2 meter. This distance is also 2 meter. Of course, this is not really at the end, but it doesn't matter because this point is what is important. And then we have, oh, okay. So this one is dx dy, and in terms of the distance, so this is 1.5 meter, and this is 1.5 meter, right? So I'm sorry, my handwriting somehow is so bad tonight. All right, and then we have the angle here. Oops. Okay, this is quite messy here. The angle here is 45 degrees, meaning what? Meaning this angle is 45 degrees, meaning this angle is 45 degrees. Alright, so we have two free body diagrams, so let's and the rest we can calculate, so we'll just focus on this. Let's label this as free body diagram, let's say ABC. This is member ABC, let's call it. This is member CD, right? So in terms of where to solve first, we can see that on the member ABC we have 1, 2, 3, 4 unknown, right? So we cannot solve straight away here for all, but on the right here, member CD, we have 1, 2, 3 unknown. So we can actually solve member CD first. So let's go with that one. So using free body diagram of member CD. So we'll begin with moment about point D, right? So summation of moment about point D equal to 0. Let's take counterclockwise as positive. So we will have counterclockwise positive. So 800 times 1.5. So 800 times 1.5 is perpendicular straight away. So NC. Okay, in this case it's perpendicular as well, right? So that angle doesn't matter because let's check with the original diagram. Is it perpendicular? Yeah, so it's perpendicular because it is perpendicular to, meaning the slot is perpendicular to how to say, the slot is parallel to this one here is parallel, right? So it should be perpendicular, the reaction. So in that case, so we'll have straight away minus NC times the distance of 3, right? So NC, the distance of 3, is equal to 0. So we will have NC equal to, so this bring to other side, divide, so become 400 Newton, right? So NC is one of the answer, right? Right, so here, so that's the answer, 400 Newton. Alright, sorry if I cough and the sound is bad for your ears. I'm so sorry about that. Okay, next is summation of fx equal to 0. If we take positive to the right, so we want to solve for dx. So there we will have dx to the right and then minus 800 Newton. Okay, so the angle will be the same, right? Because this would still be 45 degrees, right? So minus 800 cos 45, so minus 800 cos 45 degrees, and then we have NC plus NC cos 45, right? And NC we already have 400, so plus 400 cos 45 degrees equal to 0. So what's my calculator? So we have minus 800 times cos 45 degrees and then plus 400 times cos 45 degrees, and we bring to other side, so we'll have dx equal to 282.84 Newton, right? Double check. Minus 800 times cos 45 plus 400 times cos 45, 282.84. Right, so that's one of the answer as well. So next, summation of fy equal to 0 upwards as positive, so we'll have dy and then 800 downwards sine 45, so minus 800 sine 45 degrees, and then we have NC upwards sine 45, so NC, so plus 400 sine 45 degrees equal to 0. So from here dy equal to minus 800 times sine 45 degrees plus 400 times sine 45 degrees. Okay, it should be the same, right? Because sine and cosine is the same. So bring to other side, so you have 282.84 Newton. So that is the answer for that one. So we have solved 3. We need to solve 3. So now we go to member ABC. Right, so now from free body diagram of member ABC. Now, is it compulsory to write this statement? If you are in my class, it is compulsory, because any equation that is not clear, this is linked to which free body diagram, I'll just ignore it, right? So if you're my student, you know that policy from the beginning, right? Meaning that if you do not draw any free body diagram, then I'll ignore everything. If you draw like this, you have two free body diagram, but there's no label, and then suddenly a question that is come up, and I'm not sure this is linked to which, I'll just ignore as well, right? So make sure it is precise to show that you understand what's going on and it's not random and coincident. Alright, so here we'll take moment about point A. Summation of moment about point A equal to 0. So let's take, because that 600 is clockwise, so let's take clockwise as positive. So we will have that 600, and then NB is counterclockwise, so negative NB times 2, negative NB times the distance of 2. And then for this one, horizontal NC, horizontal doesn't produce any moment, the vertical one produce, so that's clockwise. So NC sine 45 times 4, and NC we already solved, right? So 400, so plus 400 sine 45 degrees with the distance of 4, that should be equal to 0. So we have 600, we have NB, and then we have NC. And then just straight away calculation. So 600 plus 400 times sine 45 times 4, you have a number, and then bring to the side, divide by 2, you have, where's my mouse, and B equal to 865.69 Newton. Double check. 600 plus 400 times sine 45 times 4 and then divide by 2, 865.69. Then summation of fx equal to 0, positive to the right. So you have ax ax and NC, right? So nothing else except NC to the left, so minus NC cos 45, so minus 400 cos 45 degrees equal to 0. So this is straightforward, so 400 times cos 45 degrees, so you have AX equal to 282.84 Newton, right? So there you go, is this 400 cos 45. Alright, and then we have summation of Fy equal to 0, taking positive upwards. So you will have AY and then plus NB, and NB is that one, right? That one, so plus NB, so plus 865.69, and then minus NC sine 45, so minus 400 sine 45 degrees equal to 0. Minus sine 45 degrees. Alright, so in that case AY equal to, so if you calculate 865.69 minus 400 times sine 45, so bring to the other side, so it become negative, right? Negative 582.84 Newton. Negative means AY is actually downward. So it means it is downward. Sorry. Alright, so we have 6 unknown that we have to solve. So 1, 2, 3, 4, 5, 6. Alright, so that's for question 1A. Hopefully that's clear and no problem there. We'll go straight to question 1B. Question 1B. So this is the diagram. So determine the internal normal force shear force and moment at point B in the beam. So that's point B here. Alright, so this is point B, meaning that when we have to find internal force, internal normal force, shear force, and moment at point B, meaning that when you cut, of course, you have that normal, shear, and moment, right? So basically what you have, where you have to cut is here, right? And the question says using the following, by using free body diagram of segment AB. So meaning that when you have cut here, part 1, you have to take this portion as your free body diagram, and part B, part 2, using free body diagram of segment BE. So this other segment over here, right? And if you understand the concept, the answer should be the same because it's the same point B that you cut. So either side, you have to get the same answer, right? Hint: solve the support reaction first before solving the internal forces. Okay, this question is really want you to solve it because normally this hint is not necessary. You should know that in this case, either side you have to solve either this one and this one, right? Because otherwise you cannot solve. So it should be based on understanding. But here the question really want to give the student the chance to know where to start. So solve the support reaction first before you can cut into the internal loading. Note, any equilibrium calculation that is not clearly specified to relate to which free body diagram will be ignored. Alright, so make sure you specify this equation is based on or for which free body diagram. Alright, so first we will draw a free body diagram of this whole thing, and alright, so we will draw a free body diagram of the whole thing and find the support reaction first before we can find the internal loading. So this is question 1B, right? So we need to find what we need to find. Okay, internal loading at B. So basically we have to find NB, VB, and MB, right? That's what we need to find, and we have two parts, part 1 and part 2. But before we solve any of the parts, again we have to solve the support reaction of the whole thing first. So first, free body diagram of the whole thing. So we have the whole bar there. Alright, we have support. We have distributed loading there, right? So now, so we have AX and AY there, and we have a force here, and then we have the normal reaction here, and then we have a force in this direction, and then we have a moment there. This moment is 500 Newton meter. This is 400 Newton with 3, 4, 5 triangle here. 3, 4, 5. And here is an C. And this one is basically 200 Newton meter times the length. So this is 4 plus 2, 6. So 6. So if you write this 200 times 6 equal to 1200 Newton, right? And then we have the here AX and AY. What about the distance? So okay, let me do this. Okay, this one is straightforward. This one is this distance, which is 4 meter. Okay, this one is interesting. What is this actual distance, right? So this is 6, right? This is 6, and it should be at the middle, so 3 and 3. So meaning from point C it is 3 meter, right? So this should be 3, and the other one is 3, but until point A you have to add another 2 here, so 3 add to 5, so this is 5. So in total 5, 8, 12, right? Until that one, so 2, 4, 8, 12, right? Yeah. Okay, between here it's 4, 6, 8, so 8, right? So that's the free body diagram. Okay, this distance here is not important. You can put it, but it's not important because it doesn't affect the calculation. All right, so this is point A. So of course we will start with solving for moment about point A. So summation of moment about point A equal to 0 will take because this is clockwise, this 500, so normally I'll just follow what's there so that it is straightforward positive, right? So that way, so if we go part by part, we have 1200 here positive, so 1200 times the distance of 5 and then NC here negative, so minus NC times the distance of 5 and 3 is 8 and then this one, okay, we do not have any thickness, right? We don't have any thickness, so meaning that this 400, the horizontal one doesn't have any moment, doesn't produce any moment about point A. The vertical does, so, and it is clockwise, so plus 400, we have vertical one becomes 4 over 5, and then the distance is 8 plus 4, 12, right? 400, 4 over 5, and then 12, and then plus 500 Newton meter there. All of this should equal to 0, so from here you can calculate what is NC. I'm sorry, I have a sore throat, so I hope your eardrums do not get damaged by me coughing here. 1200 times 5 plus 400 times 4 over 5 times 12. Oops. 1200 times 5 plus 400 times 4 divided by 5 times 12 plus 500, and then you bring over there, divide by 8. So what you get is, where am I? 1292.5 Newton. Double check. 500 plus 400 times 4 over 5 times 12 plus 1200 times 5 divide by 8. 1292.5. Okay, this is separation, right? So we are still finding separation. Summation of fx equal to 0, taking positive to the right, so we'll have ax, no, and then we have that 400 to the right, so plus 400, 3 over 5 equal to 0, right? It's 3 over 5, correct? Horizontal 3 over 5. So then 400 times 3 divided by 5, 240, but it become negative, so negative 240 Newton, meaning it is to the left, right? Okay, and then summation of fy equal to 0, upwards as positive, so we'll have ay, we assume as positive, right? Okay, minus 1200 minus 1200 plus NC, so NC is that above, so plus 1292.5, and then minus 400, 4 over 5, minus 400, 4 over 5. This should equal to 0, correct? So AY 1200, NC, which is 1292, and that 400 down. So from here AY can be calculated as, so let's see, minus 1200 plus 1292.5 minus 400 times 4 over 5. So bring to other side, so becomes 227.5 Newton. Double check. Minus 1200 plus 1292.5 minus 400 times 4 over 5. Minus 227.5, bring to the other side, positive 227.5. So obviously it is, meaning it is upwards as expected, and C of course upwards. Okay, So now we have support reaction. So we go to, okay, first is part 1 is free body diagram of segment AB, right? So segment AB. So free body diagram of segment AB. Okay, so we have to look at it. So here. So let's draw a free body diagram of that. So meaning this part here on the left, alright? So it is a short segment, something like this, where we cut it at B, meaning that we will have this, and then we will have this, and then we will have this, right? So M, B, and B, V, B. Right? And then we have support reaction. Okay, let me see. AX is not to the left, to the right. Oops. What was missing? Oh, this one. So it should be to the left. Is it? AX. Where is this X? Okay, this is AX. Right? AX should be to the left, 240. So meaning to the left, 240 Newton. AY upwards 227.5, so upwards 227.5 Newton, and then we have this distributed loading, right? So make sure you understand that when we cut over here, meaning that this portion of distributed loading, this portion here, belongs to this side, while this portion here belongs to the other side, right? So you cannot take this one 1200 is no longer valid, because 1200 is the whole distributed. So when we cut here, the distribution is only this portion. So meaning that there will be a force here only for this portion. So you have 200 Newton per meter. So 200 Newton per meter times the distance of 2 over here, 2 meter, becomes 400 Newton. Where the distance, because this is 2, so half of it is 1, so this will be 1 meter, while the rest is 2 plus 1 will be 3. Right, so from here we can solve it. So we have the free body diagram. Let's start with what is easiest one. Okay, summation of fx equal to 0, taking right as positive. So we'll have NB, and only this minus 240 equal to 0, so NB equal to 240 Newton. That's the answer. So next, summation of Fy equal to 0, upwards as positive. So we have 227.5 upwards, 227.5, and then minus 400, and then minus VB. That's all, equal to 0. So we have 227.5 minus 400 becomes minus 172.5, and VB brings to the other side, so then VB becomes minus 172.5 Newton. Yes, VB. And if we want to calculate moment, so summation of moment about point B equal to 0, so we'll use the direction, the same direction as that one, so counterclockwise is positive. So we have MB counterclockwise, and then plus 400 times the distance of 1, and then minus 227.5 with the distance of 4 to 0, right? So based on this, you can calculate. So 400 minus 227.5 times 4 minus 4, so bring to the other side, so MB equal to 510 Newton meter. 400 minus 227.5 times 4. Alright, so that's the answer for part I. And because we have I and II, right?
So next we have to find on the right side. Alright, so okay, we'll do the free body diagram. So I figure of segment. Okay, I free body diagram of segment BE. Alright, so let's draw the free body diagram. So it will be something like that. Obviously it is cut here, so you'll have it is cut at point B there, right? So you have that one, and that one, right? So M, B, V, B, and B. So I'll begin with here. So this is 500 Newton meter. Okay, and then we have something like this, where this is 400 Newton, and then we have that and C upwards. Okay, and C is already, we have already known the value, right? So we have to write the value 1292.5 Newton. 1292.5 Newton. 1292.5 Newton and C, right? And then we have the distributed loading from, meaning that it should be at the middle here, because it is middle between, meaning from C to B, the whole thing have distributed loading, so it's a middle with the distance of 4, right? So we have 200 times 4 equal to 800 Newton. Of course the total, because when we divide this way, for this free body diagram we have 800, for the above free body diagram we have 400. The total should be 1200, right? Because it's separated left and right like that. So the distance so this distance is given as 4. C and D is 4. Okay, the angle here is 3, 4, 5, and this should be the divided between 4, meaning this 4 meter divided by 2, right? So meaning that this is 2, this is 2. Okay, that's the free body diagram. So next we can straight away calculate. So based on this, okay, let's see. Summation of fx equal to 0, taken to the right as positive. So we have minus NB plus 400 3/5. Is that all? That is all, right? Equal to 0. So NB equal to 400 times 3 divided by 5, 240. We can straight away check straight away with the answer that we have up on the other side, because it should be the same. So this is 240, this 240, alhamdulillah. If suddenly you have different answer, then one of it must be wrong, right? It cannot be different answer because it's the same force. Summation of Fy equal to 0, positive upwards. So we have VB, and then we have minus 800 there, and then we have plus 1292.5, and then we have minus 400 4/5 equal to 0. Right, so if you calculate this one, so minus 800 plus 1292.5 minus 400 times 4 divided by 5, you will get 172.5, and you bring to the side, so become negative 172.5 Newton. It should be the same, negative 172.5, is it? Negative 172.5. Alright, alhamdulillah. Then summation of moment about point B equal to 0. Is it point B? Yes. And we take clockwise. We take clockwise as positive. So now we have this on the left MB there, so we have MB, and then this 800 is also clockwise, so plus 800 times 2, so plus 800 times 2. And then this 1292 is counterclockwise, so negative minus 1292.5. The distance is 4. Right, and then we have this 400 downwards, 400 4/5, so plus 400 4/5, and then the distance is 8248, the distance of 8. And then we have also 500 clockwise as well, so plus 500 equal to 0. So a lot of things to add here. So let's see. 800 times 2 minus 1292.5 times 4 plus 400 times 4 divided by 5 times 8 plus 500 minus 510, bring to the other side, become positive. So MB equal to 510 Newton meter. Is it the same as above? 510 Newton meter. Alright, so this is the same. So we have answered the 3 internal loadings for both 1 and 2. So we have covered, we have answered that one, right? So have we answered everything for question? This is question 1B. Alright, we have covered everything, right? Determine the internal blah blah blah. Okay, we have covered everything. Alright, so next is question 2. Right, so for question 1 we have finished. And what's the time now? So it's 10:39. We have should be until 10:42. So 3 minutes. So actually this to solve this question, of course while talking like this, it takes almost the full 45 minutes. Of course, at the beginning we actually use that 45 minutes to discuss a little bit on the number of questions, etc. Right? If you go straight away, it should be more sufficient, and you have time to check and double check. Of course, throughout the calculation, I've already shown also that we keep on checking. Right? So we have enough time to check. Make sure you do not have any mistake. So that's question 1B. Moving on to question 2. Okay, this is question 2A. So let's read the question. So we are 10:42. Let's consider that 10:40. So if we start at 10:40, 11:25, right? So it should be until 11:25. We should finish before 11:25. Of course, normally I'll try to add another buffer because actually it's 10 to 42, but let's assume we start at 10:40 because maybe you have some, after that question you have 1-2 minutes to just recharge or something. Alright, in figure below, the structure is subjected to forces and distributed loadings as shown. Based on all the forces and distributed loadings, determine the magnitude of resultant moment about point A and state the direction of rotation. Determine the number 2, determine the magnitude of resultant moment about point E and state the direction of rotation. Number 3, determine the resultant force and state the direction of resultant force. Note, clearly indicate which portion of your answer belong to part 1, 2 and 3. Right, okay, this is the diagram. And okay, because we cannot see everything together, right? So is this okay? I hope you can still read this one. Right, so note that, okay, this is where I think the understanding of what the question wants come into picture, right? Because just by looking at the diagram, some student may actually think that this is asking for support action, for example. So they want to search support action at this point, on this point, etc. But the question does not even ask for support action. It just simply asks for resultant moment about point A. Resultant moment about point E, right? And we are not talking about support action here. We are talking about all the forces that you can see.
meaning these forces, this force, and these forces, right? So make sure you understand first, and if you are not clear, raise your hand and ask the lecturer, do you understand the question correctly? You cannot answer, you cannot ask for the answer, because the lecturer will not give you the answer. But to understand the question, you should be able to ask, and the lecturer will answer properly, so that you understand, oh, okay, the question is asking for this one, just to verify, right? So it says, based on all the forces and distributed loading, so this force and distributed loading, find the magnitude of resultant moment about point A. So about this point, what is the summation of moment? That's simply it. And second, magnitude of resultant moment about point E, so about this point. And number 3, resultant force. That's simply just summation of forces, right? So that's important. So let's go and solve this question. Alright, so that's the diagram. Hopefully you can see. Oops, okay. So this is question 2A. Let's see the question at the same time. Alright, so in this case, we do not even have to draw any free body diagram actually, right? Because the question simply asks for resultant moment. Now, free body diagram is a must for equivalent equilibrium question, right? Before you have summation of force equal to 0, you have to have free body diagram. But this is not about equilibrium. This is just what is the moment, what is the summation of moment, right? So but to be able to do that, you have to resolve the distributed loading first, right? So we have basically, if you take a look at this, it's combination of this and then something here and then another something here, where it has something here, it has something here, it has something here, and then this is fixed, right? But that's not important. What we want to know is, because okay, this one you can divide into this rectangle and triangle. So the rectangular will be one force, the triangle will be one force there, and then we have one force downwards exactly at that point, and then this whole thing is a triangle, so it should be okay. Let me see, this whole thing is 12, so 1/3 of 12 is 4, right? So it's exactly there, coincidentally, right? In terms of the value, right? So this is straightforward, 100 Newton. This one is basically half times 500 Newton per meter times the total distance of 12 meter. So you get 1 divided by 2 times 500 times 12, 3000 Newton. Okay, that's a lot. Just verify. 1 divided by 2 times 500 times 12. Of course, because it takes a long distance there, it becomes big. And then for this one is a triangle as well, this one, so it is half times 500 Newton per meter times distance of 3, equal to 1 divided by 2 times, 1 divided by 2 times 500 times 3, 750 Newton, 750 Newton. Okay, this one is simply 500 times the distance of 3, so 1500 Newton, right? What about the distance? What about the distance? MashaAllah. Okay, let me use a different color here. Okay, this distance, so okay, for this one, because it should be at the middle, right? So it should be, the distance here is 1.5, because it's halfway to the rectangular. And then, okay, this is interesting, because this is rectangular, 1/3 to 2 ratio, so this is 3, so basically, because we have this distance and also we have this distance, right? So that portion is 2,
So meaning what? Meaning this remaining is 1 and this remaining is 1.5, so it becomes 2.5. So if you add together 2, 4, 5, 6, right? 2, 4, 6. So originally 6 as well, right? So that is the distance. And in this case, the distance, okay, this is 4. So this is the whole from here to here, right? So 6 plus 8 is 14, right? So this is 14. Right. Okay, so those are the information that you need, because you need the distance for calculating moment, right? So based on this, then okay, what is the question? The question says question 1, okay, basically 1 asks for moment about point A. Hey, moment about point A, right? And second, moment about point E, and third, this is basically summation of force, right? And the rest is also summation actually, right? So if you have already this, you have everything you need to calculate, right? So let's do now summation of moment about point A. So let's take a look. Let's take, most probably it will be clockwise, right? Because all this is big. So let's say clockwise as positive. So this is where is point A? In this point here, right? Okay, so this is point A, right? So we'll begin there. So this will be counterclockwise, so negative. So negative 1500 times 1.5, and then negative 750 times distance of 4. 2.5, 1.5, 4, right? And then plus 100 Newton there, because clockwise. Then for 6 distance, and then another one plus 3000 distance of 14 plus 6, right? Becomes 20. So equal to now I still remember marking this question. Some students actually make equal to 0. No, you have to understand, anything that is equal to 0 is because of equilibrium. So if the question is not equilibrium, do not suddenly have equal to 0. That's simply you get wrong, because it's true that you do not understand what's going on. Okay, minus 1500 times 1.5 minus 750 times 4 plus 100 times 6 plus 3000 times 20. So we have actually 55350 Newton meter. Now I'm not sure what happened with my calculator. I'm not sure if you can see. There's, so it's make it harder to see. I'm not sure if you can see that. So there's something wrong with the screen. So for examination, make sure you have your calculator in good shape. Anyway, 55350. Okay, let's check the question. It says determine the magnitude. So we have the magnitude and state the direction, right? So just note to self, state direction. This is important for me, someone like me that always forget. So we do not want to lose mark because of that. So because it's positive, so it is clockwise. So that's the answer. Now next, ME, right? Summation of moment about point E. So E is where? E is at the very end of the right. So E is here, right? So number 2, summation of moment about point E. Now given that, which direction can be Okay, because the further away is clockwise, so let's take clockwise as positive as well. But it doesn't matter because if you assume one way and it becomes negative, it's just the other way, right? But sometimes I prefer to have a positive answer, so that's why we predict at the beginning. Anyway, so ME, so at point E, so let's start with the nearest first, right? So we have this 3000 counterclockwise, so negative 3000, distance of 4, and then this one, what is the value there? 100 is also negative, so negative 100, distance of 18, and then this one become positive, so plus 750, distance of 18, 20, and then plus 1500, distance of 22.5. Then you add all of this, you will get minus 3000 times 4 minus 100 times 18 plus 750 times 20 plus 1500 times 22.5. So you'll get 34950 Newton meter, also clockwise because it's positive, right? 34950. And next we have to, okay, the direction, okay, yeah, we have state direction, and then summation of forces. So more is going down, but okay, let's just use the normal, right? So I summation of y equal to, so upwards if we take positive, so we'll have 1500 1500, and then we have 750 plus 750, and then we have minus 100, so minus 100 minus 3000, so this should be negative, right? 1500 plus 750 minus 100 minus 3000, so it becomes minus minus 850 Newton, meaning downwards, right? So yeah, you just state the direction as downwards. So is that all that is asked in this question, part 1, part 2, part 3? Okay, so that's question 2A. We can move to question 2B, right? Question 2B. Let's take a look at question 2B. Okay, this is question 2A that we have solved, and this is question 2B, but I'm not sure why my draft is stating this is part A, so this should be part B. Alright, so we have here the pruner multiplies blade cutting power with the compound leverage mechanism. So it's talking about this thing here. If a 20 Newton force is applied to the handle, so it's already shown here 20 Newton, determine the cutting force generated at A. So A is here, right? The thing that is being cut. Assume that the contact surface at A is smooth. So this is smooth. Note, any equation and subsequent calculation that is not clearly indicated to be corresponding to any specific free body diagram will be ignored and not considered. So again, so this is okay, so whatever is mentioned here is already given here, and we need to draw the free body diagram. This is an equilibrium problem. Draw free body diagram and solve for all the forces, right? So let's take a look at question 2B. Now question 2B. So we have several components here, and if you have taken the course, you have seen this before. It is in your textbook. You should know how to draw the free body diagram by now.
right? If you do not know, meaning you haven't tried the question in the book. Alright. So if I'm just to draw every member that is there, so there's one thing like this, that's the brown, that's gray thing there, and then okay, is it too big, that my drawing here? So I'll try to make it smaller. Normally I like to draw it big because it's easier to see, meaning the distance, etc. But because here on the screen we do not have enough space. Okay, and then we have this thing here, that thing, okay, roughly something like this, right? Of course this is cutting the thing there, right? And then we have that thing there, this thing DE here, and then we have oops, this thing there, right? Something like that. All right, so all the forces. So of course this thing is being cut, so we have force like that. So let's call that let's say FA. So the corresponding here, it should be upwards, FA, and here should be downwards. It should be downward, FA. And where to start? Okay, this member DE, if you can imagine, this is being compressed, so it is under compression, right? So it is being compressed like that, because this is two force member, right? FDE, so it should be just along that line, meaning along that line, along that 45 degrees, right? Because this is, oops, because this is 45 degrees. Right, so this correspond to here, here, right? So it will be something like this, FDE, and it also correspond to here, right? FDE, and of course you know the angle 45 degrees, this angle 45 degrees. Now and on horizontally, meaning the same line we have point C. So let's just assume CX CY like that, CX CY, that is corresponding with here, right? So it will be CX CY, the opposite direction, right? What else is there? There's point B. Point B is somewhere here. It is it has some distance there, 10 millimeter, right? So let's just assume this in this direction, and okay, let's go up. So in this direction, let's assume. So if you assume this is BX BY, that is corresponding to this here, right? It should be vertically upwards there. So then it will be BX BY, and then we have this force here, which is 20 Newton. Okay, my drawing is becoming worse and worse. And force here, right? 20 Newton. Now all the distance that we need. So in this case, we just to check, we have 1 2 3 points. So okay, so this is the distance. So wait, so this is point what? This is point D, right? Okay, the whole distance, because we have the whole distance, right? The whole is 150. So the whole is 150, meaning that because this distance is 25, right? So meaning the remaining is 125. Okay. This one up to point B. Okay, so this one is 150, but the remaining is 60, right? So meaning this one is 60, this one is 60, and this height is
not given, meaning this height is not given. We can calculate based on this actually, but if it's not needed, then we just leave it be first. So this one, this height is 10 millimeter, and then from E, okay, this is from E, right? From E to B is this add together, right? So this is 55, right? 25 plus 30 is 55, and then from B to A is 60. Okay. So all the things is there, and we need to find what we need to find. What do we need to find? Determine the cutting force at A. So what we need is FA, right? So FA is what? That's the only thing that is asked. Just to verify again. Blah, 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 blah. Determine. That's the only thing that you need to determine, right? So as long as we can determine that one, it's fine. Right, so let's label this. So let's say this is free body diagram 1, this is free body diagram 2, this is 3, this is 4. Normally where we start is where we have a value. So for example here, if you have 20 Newton, where's my mouse? Okay, this is 20 Newton. So we can start here, but this is too many unknown. Or we can start here, and here we have 3 unknown, right? So we can solve. So we start with free body diagram 4. So using free body diagram 4, so we have summation of moment about point, so we take about point C here. Moment about point C equal to 0. Let's take counterclockwise as positive. So in this case we have 20 here times 1.150. So 20 times 150 positive, and then here the horizontal, it's along the same line, so it doesn't produce any moment, so just vertical. So FDE sine 45, so minus FDE sine 45 degrees, and the distance would be 25. Distance is 25, equal to 0, right? So based on this, we can calculate. Okay, so bring to the other side. So 20 times 150, and then divide by 25, and then divide by sine 45. So FDE equal to 169.71 Newton. This is Newton or kilonewton? Newton. 169.71 Newton. Now we have solved that one. We can then we can actually solve Cx and Cy. But just to check whether we need to, because what we are concerned about is just Fa, right? So of course, just having FDE, it doesn't resolve for this free body diagram 2, but we can use free body diagram 1 because FDE is now is known, and here we have only 3 unknown there, so we can solve free body diagram 1, right? So then using free body diagram 1, so we'll take moment about point B. Okay, I'll just take this one so that we do not need to keep on scrolling, right? Copy, paste. Okay, just for reference. So based on this, we can do a summation of moment about point B equal to 0. Let's take counterclockwise as positive. So in this case, both horizontal and vertical will produce moment about point B. So for the horizontal, because FDE is we have already here, so horizontal FDE cos 45, so meaning 169.71 cos 45 degrees. That's this one, and the distance is 10. It's counterclockwise, right? Okay, and then vertical one, of course, is also counterclockwise, so plus 169.71 sine 45 degrees times the distance of 55, and then we have FA, which is clockwise, so minus FA times the distance of 60 equal to 0. Right, so based on this, you can calculate. So 169.71 times cos 45 degrees times 10, you get a value, and then plus 169.71 times sine 45 times 55, you get some value, and then you divide by 60. So FA, you get 130.00 Newton. So 130 Newton, that's the answer, right? So just verifying. 169.71 times cos 45 degrees times 10 plus 169.71 times sine 45 degrees times 55, and then bring to the other side and divide by 60. By 60, so we get 130. So that's the answer, because that's what we need, right? FA. So that's question 2B. Okay, so we have solved for question 2B, because next is question 3. Alright, so according to the time, 11:11, the time allocated for this one is until 11:25. So we actually have another 14 minutes. So we have 14 minutes extra from question number 2 that can be used for other question, of course. Right, so that's question number 2. Let's move on to question number 3. Okay, this is question 3A. Okay, now let's take a look at the time first. So we have 11:12. So let's consider if we have started at 11:10. If we have 45 minutes, and to 11:55. So I should finish this by 11:55 p.m. All right, for 45 minutes for this question number 3 as a whole, right? So going for question 3A. The rectangular plate is supported by a roller at A, so there's a roller here, and a hinge at B. There's a hinge there. Determine the support direction at A and B. So at this point and at this point, right? So this one, a roller, so you should know that is support normal direction upwards. This is a hinge. Hinge meaning that you can rotate only one axis. The other two axes you cannot rotate. And in terms of lateral movement, no movement is there, right? So meaning that you have five unknown support direction there, and another one at A, so we have 6 unknown in total, right? So determine the support direction at A and B. Any calculation that is not based on any Fibonacci diagram will be ignored. All right, so question 3A. So what we need is all the unknowns basically, right? Yeah. So free body diagram. So how to draw this? So we have something like that, something like that, something like that, something like that, and then we have something that's just to draw as so that it looks 3D. And let's just consider the axis, right? So its origin is here, and then we have x-axis here, y-axis here, z-axis upwards, and then we have the forces. So one force downwards here, 100 Newton, one force at the middle here, 200 Newton. Then the rest is support direction, right? So we have here and A. Okay, the way I draw it, it doesn't have any space here. So okay, let's make this go down a bit so I have enough space. Okay, so support action here. So we have this is point B, right? So you have BX, BY, and then BZ. So it cannot move anywhere, so you have that 3 unknown, and then it cannot rotate about X, so MBX. About Y it can rotate, right, that hinge, and about Z it cannot rotate, so MBZ. So you have 1 2 3 4 1 2 3 4 5 6 unknown. Now in terms of the distance, let's just so this is 4 meter, 4 meter, so 2 meter, 2 meter, right? Of course this is 4 meter. Yep. What else? That's all, right? And the rest is calculation. All right, so let's take a look at the calculation. Okay, the easiest one first. What's the easiest one? Okay, x, it doesn't have any much force, right? So summation of fx equal to 0. So we have bx and nothing else, so bx equal to 0. Settle that one. What about y? Only one here, so similarly summation of fy equal to 0, by equal to 0, right? Bz, yeah. If you want to calculate for summation of fz, you have bz unknown and also na, so we'll leave that for next. And moment about x, is there any moment about x? Yes, we have this one, this one, this one. Okay, so there's a lot of moment about x, so let's leave that behind first. What about moment about y? Okay, moment about z first, because there's nothing that rotate about z, so that's easier. So summation of moment about z axis equal to 0, so mbz equal to 0, right? Because nothing is rotating about z axis. Alright, now we use moment about y first. Summation of moment about y equal to 0. Of course this is using convention, meaning that counterclockwise about y is positive, right? So if you took all the forces, okay, all the forces here doesn't produce any moment about y. This moment is not about y. This 100 is on the y-axis, so no. So this 200 is counterclockwise about y, so 200 times the distance of 2, this distance, and then this na is clockwise, so becomes minus na times the distance of 4 equal to 0. So from there you can calculate, right? So na should be equal to, if you bring to the other side, divide, so it become 100 Newton, right? Because 2 divided by 4 is half, then times 100 is times 200 is 100. Should be correct. Now if you have solved all that one, so you have na, so then you can solve for let's do down here, right? Summation of fz equal to 0. So basically you have na upward, so 100 there, and then you have 100 downward, so minus 100, and then you have 200 downward, so minus 200 and then you have that bz over here upwards, so plus bz equal to 0. So if you calculate that, so 100 minus 100 minus 200, what should I use calculator for this one? So minus 100, bring over there, so bz equal to 200 Newton. So bz is 200 Newton. So what else is left? Fx, Fy, Fz is done. Mz, M, so Mx, right? So summation of Mx equal to 0. So you have MBX, yeah, MBX, MBX. And what else is rotating about X? So all these forces is rotating about X, right? So we'll start with NA. NA is rotating clockwise, so it's negative. So negative. NA is what? NA is 100. So negative 100 times the distance. What is the distance? This distance is 4. So 4. And then this 100 is counterclockwise about X. Also distance 4. So counterclockwise is positive. So plus 100 times distance of 4 as well. So it actually cancel out there, right? And then you have this 200 clockwise, so negative. So negative 200. Distance is also 4. What else? 1, 2, 3, tak ada yang lain yang rotate. Okay, so equal to 0. So meaning that MBX equal to, this is cancelling, this is minus 800, bring to other side 800 Newton meter. And the direction is correct, right? Because we always assume all positive here, so it is positive. It is counterclockwise. So 1, 2, 3, 4, 5, 6. So we have 6 unknown solved, right? Did we solve everything? So we have solved everything there. Alright, so moving on to question 3b. Okay, question 3b. The beam AB has a negligible mass and thickness. So this beam, negligible mass and thickness. The weight of the detective, so this is detective Pikachu here, sitting on the beam is 100 Newton. So the weight of this guy is 100 Newton. And the coefficient of static friction at A and B is mu A is 0.2. So at point A here is 0.2 and at point B here is 0.4 respectively. Determine the minimum force P required to prevent the beam from sliding down. So what is force P here? The minimum force P to prevent from sliding down. And number 2, determine the minimum force P required to push up. Okay, and then note that draw free body diagram involved in each question where calculation is involved. So you have to have the free body diagram. Now, in this case, what differentiate between part 1 and 2 is that the condition, right? Because the condition, both are impending motion. When we say what is the minimum force to do something, that's impending motion. But number 1 is impending motion that the beam is sliding down. Number 2 is it's sliding up, right? So meaning that sliding down, meaning friction is preventing it from sliding down. When it goes up, friction is going against that motion as well, right? So that's how the different in terms of free body diagram. Alright, so let's draw the free body diagram. Question 3b. Number 1 is minimum P to prevent from sliding down. Beam from sliding down. Alright, so meaning what? Meaning that if you draw the free body diagram of the beam, of course the guy here, because here in this case it's sitting at right at the middle, right? So right at the middle here. Okay, let's use a different color. So the weight is known. What is the weight? 100 Newton, right? 100 Newton. And then we have a force P here. That is also given. And the thing is, if the beam is going sliding down, okay, we have for sure what we have is normal reaction here. So this is NA, and normal reaction here, which is NB, right? So that's given because it's always there. The difference is the friction, right? And if it's sliding down, meaning that the friction is preventing it from sliding down. So the friction is on this direction as well as the friction is in this direction, right? To prevent it from sliding down. And the value of coefficient of friction is at A is 0.2, right? At A is 0.2, so at impending motion it becomes 0.2 NA, and at B is 0.4 there, so become 0.4 NB. The rest is dimension, so we have this distance of 0.3 meter, and this is basically 0.2 meter and 0.2 meter. Right, so that's what we need for part 1. So okay, what do we do here? Okay, if we take moment about point, okay, this is point B, this is point A, right? So if we take moment about point B, we can solve for NE, right, in this case. Okay, so summation of moment about point B equal to 0. So if you take counterclockwise as positive, so based on this, we take a moment about point B here, right? Okay, so NA there counterclockwise, so NA positive times the distance of 0.3, and this 0.2 NA upwards is also counterclockwise, so plus 0.2 NA. This one, the distance is 0.4. And then we have the 100 going down clockwise, so minus 100 going down with distance of 0.2. So this is equal to 0. So if we do this, first for NA part, 0.3 plus 0.2 times 0.4, you get 0.38. 0.38 NA, verifying 0.3 plus 0.2 times 0.4, 0.38 equal to 20, right? 100 times 0.2, 20. So NA, 20 divided by 0.38, 52.63. 52.63. This is in Newton, right? This is in Newton. So that is the normal reaction at A. If we already have an A, then we can solve the rest with summation of fx and fy, right? So summation of fy equal to 0, taking upwards as positive. So you have NB upwards. So NB minus 100. So minus 100 plus 0.2 NA. So plus 0.2 times 52.63. So 1, 2, 3. That's all for Fy equal to 0. So NB we can calculate minus 100 plus 0.2 times 52.63. So bring to the other side, become positive. So 89.47 Newton. Minus 100 plus 0.2 times 52.63 minus 89, bring to other side, 89 positive. Alright, so if we do then summation of fx equal to 0, taking positive to the right, so we have P, and then you also have 0.4 NB plus 0.4 NB. NB is 89.47 to the right, and then we have NA. NA is 52, so negative NA, right? So minus what? 52.63. 52.63 equal to 0. There's only 3, right? 1, 2, 3. Alright, so with this P equal to So 0.4 times 89.47 minus 52.63. You get minus 16, bring to the other side, so 16.84 Newton. Try again, 0.4 times 89.47 minus 52.63, 16.84. So that's the answer for the minimum P to prevent beam from sliding down. Now, for the other part is minimum P to push the beam up, right? So number 2, minimum P to push beam up. So meaning okay, should I'm becoming too lazy to, okay, never mind, we'll draw from the beginning, right? I want to copy and paste, but anyway, so so meaning that the beam is the same beam, and the force here is the same. So we have 100 Newton of the weight of the Detective Pikachu there, and we have P is the same, that's given. N is the same, so this is NB and this is NA. But now the friction will be different, right? Because now the beam is about to slide up, so the friction will prevent that, so it goes this way and it goes this way. It want to prevent it from sliding up, right? And mu A is 0.2, so 0.2 and A here, and this is 0.4 oops and A here, right? So if you notice, compared to the above, is the only difference is the direction of the friction. So next is the distance. So this one is 0.3 meter, and then in terms of the distance here, 0.2 meter, 0.2 meter. Alright, so we have all what we need there. So let's determine. So based on this, the same step will be applied, right? Because we take moment about, okay, let's put that this is A this is B, right? So we'll take moment about point B first to be able to solve, right? So summation of moment about point B equal to 0. Let's consider counterclockwise as positive. So what we'll have here is NA will be counterclockwise, so NA is distance of 3, right? Oh, sorry, 0.3, right? NA and distance of 0.3, but 0.2 NA is clockwise, right? So it becomes negative. So negative 0.2 NA times the distance of 0.4 0.4, and we have 100 also clockwise, so minus 100 times 0.2 equal to 0. So you'll notice that, of course, the friction is direction different, then it means that the sign here is different compared to previously. That will change the value of NA, right? So here, if we have 0.3 minus 0.2 times 0.4, it becomes 0.22. So 0.22 NA equal to 20, right? 0.3 minus 0.2 times 0.4, so 0.22. So 20 divided by 0.22, oh sorry, you get NA equal to 90.91 Newton. 90.91 Newton. So now you have NA. Wait. What is this? Okay, so I make a mistake in my drawing, right? So this one is not NA. This one should be NB, right? How come I made that mistake? Okay, so never mind, because for this calculation so far it is not affected because we take moment, but at this point we do not consider all of this force now. So NA itself, then we can solve just like before, summation of, oops,
summation of fy equal to 0, taking upwards as positive. So you have nb, and then you have minus 100, and then you have minus 0.2 na, minus 0.2, 90.91 equal to 0. So if you calculate this one, you will get minus 100 minus 0.2 times 90.91. So bring to the other side, 118.18 Newton. And then you have summation of fx equal to 0, taking to the right as positive. So you have p, and then you have minus 0.4 nb. So 0.4, 118.18, and then minus na. So minus na is 90.91 equal to 0. So you have p, you have 0.4, and then you have na. Alright. So in terms of calculation, if you use your calculator, so minus 0.4 times 118.18 minus 90.91, you get, so if you bring to the side, 138.18 Newton. Right. So minus 0.4 times 118.18 minus 90.1. Right. So now you have solved, okay, what the question one, it want P for part A, part 1, P for part 2. That's the only question that they are asking. So we have P for this one. So minimum to prevent from sliding down is 16.84. Minimum to push up is 138.18. Of course, it should be much higher because it's to push up, right? Compared to prevent from sliding down. Alright, so we have finished for question 3. We are going into question 4. So based on the time, based on just now we started at 11:10, so we have the time until 11:55. So right now it is 11:38, 39. So roughly 15 minutes. Yep. So from question before we have 15 minutes as well, right? So this one also we have 15 minutes as well buffer. So it should be sufficient. Now we are going into question 4. Okay, this is question 4, and then we have A, B, and C. So part A and B have the same diagram. So we'll go part A first. Determine the centroid of the shaded region. So this is the shaded region. We have to find the centroid. State the final answer as a coordinate. Clearly indicate how the area is divided into segments. Illustrate your calculation in table. So that's already a hint that, you know, we'll use that table for this one. Alright, so we can divide this in several ways, and normally I will divide it just by dividing it here. So we have a triangle, rectangular, and then we minus the circle, right? So we'll do this now. Okay, so that's the area. So this is question 4A. Now for centroid, and okay, we want to find the centroid, meaning that you have x bar equal to summation of x with a divided by summation of a, and then y bar equal to summation of y with a divided by summation of a, right? And we'll divide this into different segments. So basically what we'll do is, one way of dividing is right, we'll divide it in this way, right? So meaning, so this triangle, this rectangular, and minus that one, right? So basically equal to this one plus this one minus this one, right?
So in the form of a table, okay, so let's take the dimension first, because we would need the dimension. So the triangle here, this one is 6, so this is 6, and the height is 9, so this is 9. So this one will be 8, this is 8, the height is 9, of course this is 1. Now what is important is where the coordinate of the centroid, right? Now all right. So let's label this as segment 1, segment 2, and segment 3, right? So we will have segment, and then we have the area, and then we have X wave, and then we have Y wave, and then of course the calculation, right? Okay, for segment 1, right? So this triangle, so area is half times 6 times 9, which is equal to 1 divided by 2 times 6 times 9, 27. So equal to 27 meter square. X wave. So what is the coordinate of this one? The coordinate of that one is okay, so I'll use this one, right? So when you divide like this, right? So the coordinate is somewhere here of the triangle centroid, and with the ratio 2/3 1/3, so we know this distance is, because this is 6, this should be distance 2, and the coordinate from the origin, so the whole thing, because this is 2, right, meaning that what, this is 8, this is 6, okay, 8 6, meaning this is 2 here, right? So this is 2 and this 2, so it becomes -4, right? So this become -4, the coordinate, right? And this distance is, because okay, the whole thing is 9, the height is 9, so meaning that this is 3, this is 6, right? Meaning in terms of the ratio. So if this is 6, below is 4, so meaning this is 2, right? 6 minus 2, right? So so this is positive 2. Okay, so that's the location there. Moving on to segment 2, which is the rectangular. So the area is simply 8 times 9, which is 72, right? So the so we are talking about, we're talking about this rectangular, and it is roughly there, right? The centroid. So meaning, because this is 8, so from here is 4, from here is 4, so meaning because this is 2, so this distance is 2, so X wave is 2, while Y wave is, because the whole thing is 9, so 4.5, 4.5, so because this is 4, so it's just 0.5 there, right? Oops, sorry, this meaning 0.5. And what about the circle there? The area is pi r square, so r is 1, square is simply just pi, but it should be negative here, so negative here. Negative pi r square, so negative pi. Coordinate for x coordinate is 4, so straightforward. Y coordinate is -2. Alright, so the rest is calculation, right? So let's go on. So in terms of the calculation, 27 times -4, so -108. 27 4 108. 27 times 2, wait, how is that possible? 27 times 4, okay, 108. 27 times 2, 54, alright. So 54 positive. Next, 72 times 2 is 144. 72 times 0.5 is 36. Now here, negative pi times 4 is negative 4 pi. Negative pi times 2 is 2 pi. So, you know, 2 pi that goes on to the 3. Anyway, that's a Malay joke. So the area, summation of area, 27 plus 72 minus pi. You get 95.8584 if you take the whole thing, right? 95.8584. What about this one? Summation of x with a minus 108 plus 144 minus 4 pi. 23.4336. Okay, and then 54 plus 36 plus 2 pi. 96.2832832. Okay, so from here x bar equal to 23.4336 divided by 95.8584. You get 23.4336 divided by 95.8584. You get 0.244. 23.4336 95.8584. Okay. Y with y bar, sorry, 96.2832 divided by 95.8584. 96.2832 divided by 95.8584. 1.004. Okay, so this is meter, right? So in terms of the coordinate, because the question asks for coordinate, right? Is it? Determine the centroid. Centroid is a coordinate, right? Okay, anyway, so x bar y bar equal to 0.244 1.00 meter. That's the answer. Alright, so that's question for A. So we have complete question for A. Next, question for B about inertia. So question for B, determine the moment of inertia about x-axis. So we need to find Ix. Clearly specify all equations used in the calculation. Clearly indicate the area, how the area is divided. Now, equation that we will be using is basically it is given in the table here, right? For example, for triangle, for rectangular, and for circle. Right. So, we will divide the same as part A, and then because we will be using parallel access theorem for this one, right? We will be using parallel access theorem, meaning what? Meaning this is question for B. We want to find Ix, right? Ix what? So we'll be using Ix equal to, okay, this looks like T, Ix equal to Ix prime plus A dy square. Right? So how we'll divide the shape is basically just the whole thing, right? We'll divide the same as before. So basically this is divided as such. So it is basically equal to Okay, right now because we are considering about ix, so the distance, the y distance is what we want, dy, right? Okay, so for the triangle, basically we have the triangle and then plus the rectangle and then minus the circle, right? So okay, for the rectangle, so the centroid is here, so the centroidal axis will be there, right? The y prime, so something there, and the x-axis, sorry, not y prime, x prime, the x prime. And the x is on the lower part, if you look at that, right? So x is lower part. So what is the distance between the two axes, right? So so basically, because if we have divided like that, so it's somewhere here in terms of the height, because this is 9, meaning that this is 3 and this is 6, right? 2/3 and 1/3 ratio. So what is this? Because this is dy, right? So because the whole thing is 5, this one is 3, so meaning this dy is 2, right? So meaning that this is 2, while sorry, so I shouldn't draw on that. So meaning that this is 2 basically, right? In terms of height, and so this one is 6, this height is 9, right? And the distance between the two axes is 2, right? For this one, the central axis is at the center there, so that is x bar and x prime, sorry, and x is a bit below there, right? X. So because the whole thing is 9, the middle is 4.5, so the distance between 4.5 and 4 here is 0.5. So dy is 0.5, right? And the distance here is 8 and this is 9, right? And for the for this one, the centroidal axis is basically there, that's the x prime, and then x bar is above, as you can see there. So the distance is simply from here to here, right? So it's 2, distance is 2, so the distance is simply 2, and the radius is simply 1. Alright, so those are the information that we need, and then we can calculate using this parallel axis theorem. Okay, another equations that we need or we will be using is what we can get from here, right? So basically for rectangular, Ix equal to triangle 1/36 BH cube. For rectangular, Ix, this is of course Ix prime, right? In this case, 1/12 BH cube, and Ix here equal to 1/4 pi r power 4, right? From there. Right, so going back to the question there. Alright, so solving this is simply just using this one, right? So basically Ix equal to, so if, because we have two parts, right? Ix prime and then a dy square. So Ix prime here is simply just 1/36. B is 6, h is 9, right? So 9 cube. Plus a, basically half, the area is half 6 9, right? And then we should multiply by dy square. So dy square, dy is 2, so 2 square. So a dy square, and then here plus 1/12 bh cube, so 8 9 cube, plus a is 8 times 9, and then dy is 0.5 square. and then we should minus this circle, so minus 1 over 4 pi 1 to the power 4, and then minus area is pi 1 square, pi r square, and then dy is 2, right? So 2 square. Right, so based on that calculation, so if we simplify 1 by 1, 1 divided by 36 times 6 times 9 power of 3, you get 1 to 1.5, so this equal to 1 to 1.5, and then 1 divided by 2 times 6 times 9 times 2 square, you get plus 108, and then plus 1 divided by 12 times 8 times 9 cube plus 486 8 times 9 times 0.5 square, it is plus 18, and then minus this one becomes pi over 4, right? Because 1 is there, and then minus 4 pi basically. So if you add all of this, 1 to 1.5 plus 108 plus 486 plus 18 minus pi divided by 4 minus 4 pi, you get 720. Mana mouse? 720.15 meter to power 4. Right, so that is Ix. The question only asks for, the constant only asks for moment of inertia about x-axis, right? Alright, so that's for this is for okay, wait, which one I have clicked? So this is for B, sorry. For A is before that. For B, so moment of inertia about x-axis. So we can go for part for C, right? Question for C. Okay, so we'll go to question for C. Alright, so this is for C. Based on this figure, determine the moment of inertia of the area about y-axis. So this is by integration. Determine the moment of inertia of the area about y-axis. Okay, so this question did not specify any element. We can use horizontal, we can use also vertical. Both will give you the same answer, but I will use vertical for this one because that's easier. Because this is moment of inertia, right? Okay, yeah. So because moment of inertia, alright. So we'll go straight into question for C. Now, if you want to find Iy, and if you want to use using integration of x square dA, this is valid for horizontal. Horizontal. Astaghfirullahalazim. Is for vertical element, right? Because this is Iy. Ix will be for horizontal, Iy for vertical, right? Because it's parallel to that axis. So if you want to use horizontal, you have to use parallel axis theorem. So why should I use that one? So we'll use the straightforward one, and it's straightforward here, right? So basically, if the shape is like this, okay, and they have the x-axis and y-axis there, so I will be using a vertical element, right? Using vertical element, and here you know that y equal to 0.25 x cube, and here the limit will be from 0 to 2, right? That's the limit. All right. So if you take out the horizontal element, so the vertical element, so I'm sleepy already, it's 12 AM. Okay, so this will be dx, and this height will be y. right? And of course y equal to this one. So dA here is simply y dx, and y you can straight away plug in here, so meaning that dA equal to, you plug in there, so 0.25 x cube dx. So we can use that straight away. So by using the equation above, so when you have I x equal to integration of from limit 0 to 2, so 0 to 2 x square, and then times dA times 0.25 x cube dx, right? So the rest is just integration. So simplify, this becomes 0.25 x to the power of 5 dx, so equal to, when you integrate, 0.25 x to the power of 6 divided by 6, and then the limit is 0 to 2. So 0.25 and then 2 to the power of 6 divided by 6. So if you just use your calculator, 0.25 times 2 to the power of 6 divided by 6, you get 8 over 3, right? Or 2.667 meter to the power of 4. Right? Or basically it's 8 over 3. But in decimal point is 2.667, because 666, right? 2.667 to the power of m to the power of 4. So that's the end, right? So because after this there's no more. So yeah, that's the final. So we have accomplished this one. So 12:06. So if you remember at the beginning of the time, what is the time, where did I note that one? We begin at almost 10 p.m, right? So if we actually use 3 hours, it should be around 1 a.m. But now it's 12:07 a.m, so meaning that we actually have a buffer of almost 1 hour. So meaning that if you have the discipline of knowing what to do with each of the question, you can answer all the question correctly with 1 hour to spare, actually, right? But of course it depends on the length of the question. If you go back to the previous simulation, I think it's less than 1 hour buffer, right? Maybe 45 minutes or something. Yep. So of course the question is not exactly the same length, etc. But all of the questions should be possible to be answered much less time compared to what is being given, the 3 hours. Alright, so it's already midnight. I'm not sure if you can see my eyes is already red. It's 12 a.m. It has been a long day and I need to go back home. Of course, it's a midnight in the office now. Alright, so that's all for this one. So yep, I hope that based on these two simulation, the previous one and this one, you can see how we deal with questions, different type of questions in the final exam, and hopefully it helps one way or another for your preparation for your final exam. And all the best, inshallah. Yeah, all the best for your exam. Make sure you are well prepared, make sure you are calm and collected and addressing all the questions systematically, and inshallah all will be okay. So with that, we'll end the video here. Thank you very much. All the best in your exam. Wassalamu alaikum warahmatullahi wabarakatuh.